Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fourth question from the preliminary exam which was written in the year of 2023 at the Torah Academy. Please do expect a total number of 12 videos since the question paper had 12 questions in total, and that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please guys, help us grow the channel by just subscribing. Okay, I'm supposed to determine the derivative of f of x from first principle, where k is just a constant term. Okay, there is an equation we use, guys, to find the derivative, right? It simply says derivative is basically equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Limit as h approaches 0. How can you find f of x plus h? We are simply going to substitute x plus h whenever you come across x in the equation of f of x. Né? So this will just be equal to k x plus h squared minus k minus f of x, which is just k x squared all over h. Né? There's limit, and as h approaches 0, if I remove the brackets over there, if I would simply remove the brackets, I'll be left with k. I'll be left with k x squared plus 2 k x h plus k h squared minus k x squared all over h. The entire purpose, guys, of finding the derivative from using first principle is to just substitute to 0 whenever we come across h. But right now we cannot do that because the denominator will be equal to 0. And if the denominator is equal to 0, the entire expression will just be equal to 0. So this will just be limit as h approaches 0. This guy will subtract with that one. I'll be left with 2k xh plus k h squared all over h. Now I can take out a common factor over there, which is just h. I'll be left with 2kx plus kh all over h, and then these two will simply cancel one another, and then I'm left with limits as h approaches 0 of 2kx plus kh. Are we together? And then now I can substitute h as 0, guys, because the expression will never be undefined. So I'll simply have 2kx plus k multiplied by 0, and then the answer is just 2kx. So the derivative from first principle is basically equal to 2kx. Are we together, guys? Okay. Now, let me erase this part because it will disturb me a bit. Okay, now I'm asked to determine the following. Nah? This notation, guys, tell me that I need to derive with respect to x everything that is inside the brackets over there. But for me to derive, guys, there is a rule that I use such that if f of x is equal to a times x to the power n, therefore the derivative of f of x will simply be equal to n multiplied by a and then x to the power of n minus 1. Just take the exponent, multiply the coefficient, and then subtract 1 from the exponent. Okay, but before, guys, we apply this rule, we need to make sure that the variable we are supposed to derive is not at the denominator. The variable we are supposed to derive is not inside the brackets. The variable we are supposed to derive is not in set form. Are you together? Set form simply means the variable should not be under a square root. So over here I do have my variable under a square root. That means before I find my derivative, I must remove that square root. I'll still have x over 3 multiplied by x to the power 1 over 2. Remember, there's a rule, guys, in exponents that simply says a root of a number is always a denominator of its exponent. So that's basically 1 over a. Are you together? Okay, and then if I'm multiplying, guys, bases that are the same, I can simply take one exponent. I can simply take one base and then add exponents. Now, I have 1 plus 1 over 2. That will just give me 3 over 2. All over, I still have over 3 over there. Né? Or this thing can be rewritten as 1 over 3 multiplied by x to the power 3 over 2. And please note that, guys, before I find my derivative, I will keep on writing this statement of mine, because this notation is the one that reminds me that I need to determine the derivative. If now I'm finding the derivative, I do not need to write that statement, because I don't need to I don't need to remember now, because I have found the derivative. Né? So now finding the derivative, I'll simply use this rule. I will have 3 over 2 multiplied by 1 over 3, and then x to the power 3 over 2 minus 1. And then my derivative will basically be equals to 1 over 2 x to the power of 1 over 2. And that's how you should have derived that. And then now I'm supposed to derive the equation of y with respect to x. So basically, I must just isolate y. If I'm given x squared minus 20x minus 4y, x squared is equal to 20x minus 4y. Now, I'll just take the 4y to the other side. I'll end up having positive 4y being equals to 20x minus x squared. And then y is just I'll just divide every term by 4. Y is just equal to 5x minus 1 over 4 times x squared. Therefore, the derivative of y with respect to x will simply be 5 minus 1 over 2x. This will be my derivative. And that's how, guys, we're supposed to tackle the question over there. So please, guys, do stay tuned and wait for more videos. Thank you.